The Navy has developed some ships made out of aluminum, and stick welding, the shielded metal arc welding process, does not work well for aluminum. So we had to develop. We're trying to get ahead of the ball and develop a process that we can use for supporting underwater repairs to these ships. So we had to develop a gas metal arc welding procedure for being able to perform underwater dry chamber aluminum welding repairs.
The LCS-2 class vessel is a rather large ship, some 418 feet in length and 104 feet in breadth. Dry docking this vessel is extremely expensive. Placing the blocks in the dry dock in the exact locations is time-consuming and laborious. If the Navy can repair a hull without the need of dry docking, that's the best choice.
Nobody has ever attempted underwater aluminum welding, whether it be in an academic level or in a professional field of any sort, and we've had to kind of from the ground up figure it all out.
When we speak of underwater use, this is always going to be in a dry chamber or habitat environment.
It's about 6 feet tall by 4 foot wide, 4 foot deep, and we are welding at 23 feet of seawater.
Because aluminum is so susceptible to moisture, we're actually mitigating the atmosphere within that dry cofferdam or habitat.
The number one problem we have is what's called porosity in the weld, and essentially that's just gas being trapped in the weld, and it shows up as bubbles in an x-ray, and they're little gas voids in the weld, and too much of it can lower the strength of a weld.
A lot of companies didn't want to get involved with this type of work, and you know, it I guess imposed a little bit of risk on the company that they were going to have to lend us some equipment before we were able to buy anything. Lincoln was very friendly and allowing us to actually borrow some equipment and doing our initial testing, and because of that, it allowed us to get where we are today.
Lincoln techs come down here and just swing by. They'll be in the area and just come in and say, how you doing, how's the equipment running, and we'll have some questions, and they're just like on it, and they've got the answers.
We're using the PowerWave S350 to drive a PowerFeed 25M wire feeder, and we're using the super glaze wire.
We're using right now what's called the Power Mode 40, and essentially the parameters came from Lincoln.
Welders can now concentrate on their bead profiles rather than thinking about what they have to do that a machine cannot do for them. Voltage and amperage controls and wire stick out length, all of these factors come into play, and the Lincoln machinery is well suited to some very technical welding.
We have kept it on for probably 8 months straight. We haven't turned it off one time, and it's run just as well today as it did the day we plugged it in and made it hot.
The boards inside these machines are actually potted about a ½ inch thick. There's no chance that in the marine environment, corrosion is going to attack the circuit boards in this equipment. The wire feeder itself is small enough to go through most hatches and access points into bilges or right down to the keel of a vessel.
One of our obstacles we've had to overcome is the distance from the wire feed unit to the gun itself, and basically that's because of mobility on the job site.
The super glaze wire feeds a complete 50-foot push-pull circuit without any collapse of the column strength, and we've not parted any of the wires in the conduit. Feeds right through the spring-loaded tip very well, and we've experienced no feeding problems at all with this lineup.
We're red for life. Lincoln has supported us so well, and I can't see any reason to move to a different company, a different supplier. They've been there with us from day one of this project, and there's no reason to leave Lincoln whatsoever. They're a great company.
The Navy's aluminum fleet is growing as we speak. As they build more of these ships and establish their overseas home ports, Phoenix looks forward to supporting the Navy in topside and underwater aluminum welding repairs.